Hello students, hope in these trying times of COVID, you're all safe and healthy. I'm Dr. Seema Singh and you're watching my channel Bonding with Chemistry. Today we will continue with part 7 of chapter 3 Metals and Non-Metals. For recap, this is the list of topics that I've already covered in my previous videos. In today's video, we'll continue with the third chemical property of metals, their reaction with acids. My dear students, hope you recall that we have briefly studied this topic in the previous chapter, Acids, Bases and Salts, under the subheading Reaction of Acids with Metals. The link for your reference is provided on top of this video in the info section. In my upcoming video, we will learn how metals react with solutions of other metal salts. So don't forget to subscribe to my channel and do please press the bell icon for receiving the latest notifications. In my last two videos, we have been trying to arrange various metal samples in order of their decreasing reactivity on the basis of their reaction with oxygen and water respectively. Let us quickly recall that on performing activities that involved collecting various metal samples and arranging them in decreasing order of their reactivity with oxygen and water respectively, we arrived at these two orders. And we also concluded that the reaction of metals with oxygen as well as with water does not help in providing us a detailed list of the reactivity order, as many metals occupy the same slot, as you can see here. Today we will try to further segregate or divide or rank this series by performing an activity which involves reaction of metals with acids. We have already learned in my video on reaction of acids on metals that metals react with acids to give metal salt and hydrogen gas. Also, the reaction is exothermic, wherein heat is evolved. For example, when metals such as zinc reacts with acids like dilute hydrochloric acid or dilute sulfuric acid, it displaces hydrogen from the acid, which is liberated as hydrogen gas. You can see here. So zinc is going to displace hydrogen and that hydrogen is going to be liberated or evolved as hydrogen gas. The metal combines with the remaining part of the acid. So hydrogen is released as hydrogen gas. The remaining part is Cl here and SO4 here to form the corresponding metal salt, zinc chloride and zinc sulfate respectively. The acid here could be strong acid like hydrochloric acid and sulfuric acid, or they could be weak acid like acetic acid. Here too, zinc is going to displace hydrogen from the acid. This hydrogen is going to be liberated as hydrogen gas. With the remaining part, that is the acetate ion, zinc is going to combine to form zinc acetate. Well students, now this part is important. Nitric acid is also a mineral acid along with hydrochloric acid and sulfuric acid. But instead of hydrogen gas, it produces water on reaction with metals. The reaction of metals with nitric acid is very important from your examination point of view, and so I will discuss it separately in this video itself in a short while. Now to understand how reaction of metals with acids helps us in deciding the reactivity of a metal, let us perform a simple activity. Learners note that since this activity has already been discussed in the previous chapter in detail, so we will quickly recall it. For this activity, we will add few pieces of zinc granules carefully to a boiling tube or a conical flask containing small amount of dilute sulfuric acid or dilute hydrochloric acid. For better safety, we can take zinc granules in the test tube or conical flask first, and then with the help of a thistle funnel add the required amount of sulfuric acid or hydrochloric acid. We observe that a chemical reaction begins the moment the metal and the acid are mixed. This can be inferred because of small bubbles that we observe on and near the zinc granules. Now, the bubbles that are evolved briskly or at a rapid speed suggest the evolution of a gas. To test the gas or to find out which gas is evolved, we pass the gas through a delivery tube into a trough containing soap solution as shown in the figure. But remember, it is not necessary to take soap solution. For more details on this, you can refer to the video on reaction of acids with metals. Now, when a lighted candle or splinter is brought near one of these gas-filled bubbles, the gas immediately catch fire and the flame burns more brightly, accompanied by the pop sound, as you can see here. This shows that the evolved gas is hydrogen. Also, we observe that the boiling tube or the conical flask became warm due to the reaction, which suggests that the reaction of metals with acids is exothermic in nature, implying heat is evolved. The students, we had two major observations here. One, hydrogen gas is evolved when metals react with acids, and number two, the temperature increases. You can measure the temperature change with the help of a thermometer. And on the basis of these two observations, we can determine the reactivity of different metals with acids. The metal that reacts more vigorously with acids or where hydrogen gas is evolved more rapidly and where we see more heat being evolved is definitely more reactive and will be placed higher in the reactivity series. Let us now perform another similar activity that involves collecting few metal samples and treating them with dilute hydrochloric acid. We will take up only those metals which are mentioned in NCERT. Dear students, a word of caution: do not perform this activity with sodium or potassium. This is because these metals are highly reactive. You learnt in my previous videos that these two metals react vigorously even with cold water. Their reaction with acids could be explosive, leading to an untoward incident or a mishappening. So I repeat, do not collect and perform experiments with sodium and potassium. They could be explosive. So these are the metals which we will react with dilute hydrochloric acid. All of them are readily available in your science laboratories. If in case the metals are tarnished, you can rub them clean with the help of a sandpaper. Put the samples separately in test tubes or conical flasks containing dilute hydrochloric acid. Also suspend thermometers, ensuring that their bulbs are dipping or immersed in acids completely. Observe and note: number 1, the rate of formation of bubbles, and number 2, the increase in temperature if any. Based on these two observations, you are supposed to arrange the metal samples in the decreasing order of reactivity with dilute hydrochloric acid. Coming to the observation, we will observe that the maximum bubbling of hydrogen gas is observed during the reaction of magnesium with dilute HCl, followed by that of aluminium, zinc, and iron. In iron, we witness minimum or least bubbling, whereas no gas bubbles are observed when copper metal is added to the acid, which suggests it does not react with dilute hydrochloric acid at all. Also, the rise in temperature follows the same order. Maximum heat is evolved during the reaction of magnesium, followed by aluminium, zinc, and iron. No temperature change is observed in the case of copper and dilute HCl. The corresponding equations for these reactions can be written as follows. Students, note that you can write the word aqueous abbreviated as AQ instead of dilute to illustrate the physical state of acid. Both of them are accepted. The reaction of metals with dilute sulfuric acid are also similar to that of dilute hydrochloric acid. But instead of metal chlorides, we get metal sulfates here. Here too, you observe that copper does not react with dilute sulfuric acid. But remember, it does react with hot concentrated sulfuric acid. The reaction is beyond your class level. My dear students, I have intentionally missed out the reaction of sodium and potassium here. Although those reactions are very simple, but just because of ease with which you can remember the reaction, you should not be tempted to perform those reactions. What I mean to say is, suppose I ask what happens when sodium reacts with hydrochloric acid dilute. You will be quick to complete the reaction and say NaCl and hydrogen gas will be released. Now this reaction looks very simple, and probably if somebody asks you give an example of a metal reacting with dilute hydrochloric acid, it might come as the first reaction to your mind. But just because this reaction looks so simple, do not be tempted to perform this reaction. Same is with potassium. Potassium, when it reacts with hydrochloric acid, you can quickly complete the reaction and say potassium chloride and hydrogen gas will be liberated. Thus, on the basis of reaction of metals with dilute hydrochloric acid or dilute sulfuric acid, we can arrange the given metal samples in decreasing order of their reactivity as follows. Magnesium most reactive, followed by aluminium, zinc, iron, and finally copper, which doesn't react with dilute hydrochloric acid as well as dilute sulfuric acid. Well, now if we look at the actual reactivity series, we can say that all those metals that are placed higher or above hydrogen can displace hydrogen from dilute acids such as hydrochloric acid and sulfuric acid to produce hydrogen gas and metal salt. Let us try to understand the reaction of metals with acids on the basis of electron transfer. Dear students, note that this topic is only for your additional knowledge. It is not a part of your CBSE or NCERT syllabus. So let us try to understand. We know that metals have the ability to lose electrons. So if I represent any metal with M, it has a tendency to lose electron and form positively charged ion known as cation. For example, magnesium. Magnesium, the electronic configuration is 282. In order to obtain the octet or the noble gas configuration, this magnesium has a tendency to lose these two electrons, you can see here. And when it loses two electrons, it converts into magnesium 2 plus ion or magnesium cation. Now coming to the acid, let us say the acid we take is dilute hydrochloric acid, and hence the word AQ. Dilute hydrochloric acid is going to ionize into H plus ions and chloride ions. Now when metal is added to acid, the H plus ion is going to take electrons from the metal and convert into hydrogen atom. Now this hydrogen atom is quite unstable because it has only one electron. In order to complete its duplet, it is going to combine with another hydrogen atom to form hydrogen gas. And the remaining part of metal is the positively charged ion. This positively charged ion is going to combine with the negatively charged ion to form the corresponding salt. For example, magnesium when reacts with hydrochloric acid, it is going to release this H positive ions as hydrogen gas, and the remaining metal part, that is Mg2 positive, is going to combine with Cl negative to form magnesium chloride salt. Let us now move on to the reaction of metals with dilute nitric acid. Nitric acid with chemical formula HNO3 is also known as Aqua Fortis, which in Latin means strong water. When metals react with dilute nitric acid, which is also an example of mineral acid, they give metal salt, water, and oxides of nitrogen. Well, actually, here too, just like in reaction of metals with dilute HCl and dilute H2SO4, hydrogen gas is initially evolved. But nitric acid being a strong oxidizing agent. Now, what does an oxidizing agent means? An agent which can supply oxygen. So nitric acid being a strong oxidizing agent converts or oxidizes this hydrogen to water. And when it oxidizes hydrogen to water, it itself undergoes reduction, and so it itself gets reduced to any of the following oxides of nitrogen: nitric oxide, or also known as nitrogen monoxide since you have just one oxygen, nitrogen dioxide, you have two oxygen, or nitrous oxide, dinitrogen, there are two nitrogen, dinitrogen monoxide. Now this nitrous oxide is what is known as your laughing gas. Don't worry, you'll be studying about all these oxides of nitrogen in your higher classes. Now remember that the type of oxide which is going to be formed depends on number one, the nature of metal, number two, the temperature of the reaction, and number three, the concentration of nitric acid. Whether you're going to use dilute nitric acid or concentrated nitric acid, depending on the concentration, the oxide will change here. For example, when zinc reacts with dilute nitric acid, it gives nitrous oxide. And when the same zinc reacts with concentrated nitric acid, you have nitrogen dioxide as one of the products. Here you can see that copper, which otherwise does not react with dilute sulfuric acid and dilute hydrochloric acid, react with both dilute as well as concentrated nitric acid to give rise to copper nitrate. You have the same product here, copper nitrate, water, but different oxide of nitrogen. When copper reacts with dilute nitric acid, you have nitric oxide, whereas when copper reacts with concentrated nitric acid, nitrogen dioxide is produced. Students note that these chemical equations are only for your additional knowledge. You don't have to practice them, you don't have to learn them, you don't have to know them as far as your board examination are concerned. They are to be studied in higher classes. In fact, there are no direct chemical equation from the reaction of metals with dilute nitric acid provided in your NCERT textbook and CBSE syllabus. As far as your class level is concerned, most of the times you have reasoning question from here, and therefore this topic is an important topic. The first reasoning question that can be put up from this topic is, why hydrogen gas is not evolved when metal react with dilute nitric acid? I've already told you the answer. Nitric acid is an oxidizing agent, therefore it oxidizes the hydrogen gas which is evolved into water. The second reasoning question, which is slightly more important, is which metals produce hydrogen gas when reacted with extremely dilute nitric acid? Yes, you heard that correctly. There are exceptions. Magnesium and manganese metals do react with extremely dilute nitric acid to produce hydrogen gas instead of water. But here you need to take care that the nitric acid used for the reaction is very, very dilute. By extremely dilute, I mean the concentration of HNO3 is just 1%. Now, what does this 1% means? For example, you have a beaker of say 100 ml capacity, right? You're going to take in this beaker 99 ml of water and add 1 ml of concentrated nitric acid to it. The resultant solution is known as 1% HNO3, which has a fairly large amount of water and a very, very small amount of nitric acid. Due to this dilution, the nitric acid's oxidizing ability is drastically reduced, and thus it is unable to oxidize the hydrogen produced to water. For your knowledge, I am also providing you the equations for the reaction of very, very dilute nitric acid with magnesium and manganese. I would suggest you do practice these two equations because of the importance of this question. Coming to the reaction of precious metals with acids, silver, gold, and platinum are placed below hydrogen in the reactivity series and thus are expected not to react with dilute acids. Although gold and platinum do not react with any of the three mineral acids. It could be dilute H2SO4 or it could be your hydrochloric acid or nitric acid. But silver does dissolve in hot concentrated sulfuric acid and react with dilute and concentrated HNO3 just like copper. The reason we'll leave for you to study in your higher classes. So now, on the basis of the reaction of metals with acids, we can update the reactivity series that we obtained from the previous reaction of metals with oxygen and water. The updated series after the reaction of metals with acid looks like this. You can see here, this one. We can see that we could further segregate aluminium and zinc. You can see here, aluminium and zinc occupied the same slot when they reacted with water. But here, since zinc is less reactive as compared to aluminium, it occupies a lower slot. Although copper is more reactive than gold and silver, as seen in the reaction of metals with oxygen, here we place copper and silver together, as both of them show reaction with hot concentrated sulfuric acid and nitric acid. But gold does not react with any of the three mineral acid, and therefore we place it in the last slot. Thus we see that although reaction of metals with acids has further helped in subdividing or subranking the series, yet we see there are still few metals that occupy the same slot, for instance copper and silver. Therefore we conclude that reaction of metals with acid has also not been able to provide a detailed categorization of these metals as per their reactivities. So we need to perform more experiments or reaction that will help us in obtaining the reactivity order as provided in the actual reactivity series. We will be studying about these reactions in my next video. Now students, I mentioned a little while ago that gold and platinum do not dissolve in any of the three mineral acids. But is there an acid that dissolves these noble metals? Yes, and the name of that acid is Aqua Regia. Now, Aqua Regia in Latin means regal water or king's water, and also is known as royal water because of its ability to dissolve noble metals such as gold and platinum. You see, gold isn't dissolved by any of the three mineral acids. Aqua Regia is able to do this, so it is powerful, royal, or like a king, and hence the name Aqua Regia. Aqua comes from the word water, and Regia is royal, king. Aqua Regia is not a single compound, but it is a mixture of two acids, concentrated hydrochloric acid and concentrated nitric acid, in the ratio of 3:1 by volume, which means 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid are mixed together to form aqua regia. Students, it is a highly corrosive fuming liquid which when prepared fresh is colorless but within seconds turn yellowish orange or orangish red in color. The detailed mechanism involving reactions of aqua regia are beyond your current class level. Also remember, not all metals can be dissolved in this chemical. For example, silver does not dissolve in aqua regia. We will leave the reasoning part for your higher classes. Here are the images illustrating the dissolution of gold and platinum by aqua regia. You can see here. Here you added a gold coin, the second step and the third step. In case of platinum, these are the platinum coins and you can see what happens to them after some time. Aqua regia finds use in the extraction as well as purification of both gold and platinum. It is also used for reviving or restoring the lost shine in gold ornaments, and sometimes the customers get tricked or fooled too. Well, actually, there is an interesting and famous incident in history about Aqua Regia. Let me narrate that incident to you. During World War II, two German Nobel laureates, Max von Laue and James Franck, had sent their gold Nobel Prize medals to the lab of Niels Bohr in Denmark for protection of being confiscated by the Nazis. This was because the German government had prohibited Germans from accepting or keeping any Nobel Prize after a German journalist and peace activist who was awarded Nobel Peace Prize in 1935 was jailed on charge of treason and espionage, that is spying. At that time, my dear students, it was illegal to take gold out of your country. And if it had been discovered that these Nobel laureates, Lua and Frank, had done so, they could have faced prosecution in Germany. When the Nazis reached Copenhagen, George D. Hevese, a Hungarian chemist working in Bohr's lab, dissolved those gold medals in Aqua Regia in order to protect them. He placed the resulting solution on the shelves in the laboratory along with several other chemicals. The Nazi soldiers completely ignored the beakers of yellow liquid. After World War II was over, Hevese returned to find the solution undisturbed, and he reprecipitated the gold out of the acid. He returned the gold to Royal Swedish Academy of Sciences in Stockholm and the Nobel Foundation. They recasted the medals and returned it to their rightful owner, Laura and Frank. My dear students, I will strictly advise you not to perform any experiments with Aqua Regia in your science laboratories. It is a highly corrosive acid and it might lead to a mishappening. Finally, let us put to test what we have learned by answering the following questions. My dear students, I will advise you to try answering them yourself. In fact, you can take it as a 10 to 15 minutes revision test, maybe after a small break. In case you get stuck up, you can always look at the answers and the explanation that I have provided. Starting with the first question, which gas is produced when dilute hydrochloric acid is added to a reactive metal? The gas is hydrogen. Write the chemical reaction when iron reacts with dilute sulfuric acid. So iron will react with dilute sulfuric acid to give rise to iron sulfate and hydrogen gas will be evolved. You can check your answers here. The next question says, name two metals which will displace hydrogen from dilute acids and two metals which will not. So any two metals which are above hydrogen, the reactivity series, you can put their names in those metals which will displace hydrogen. It could be sodium, calcium or aluminium, zinc. And any two metals which are placed below hydrogen, for example, copper and silver or gold and platinum, you can write it as metals which will not displace hydrogen from dilute acids. Moving to the next question. The question says, a man went door to door posing as a goldsmith. Your goldsmith is Sunar in Hindi. He promised to bring back the glitter of old and dull gold ornaments. An unsuspecting lady gave a set of gold bangles to him, which he dipped in a particular solution. The bangles sparkled like new, but their weight was reduced drastically. The lady was upset, but after a futile argument, the man beat a hasty retreat. Can you play the detective to find out the nature of the solution he had used? Now let us break the question into parts. The lady gave gold bangles. Now these gold bangles were old and dull. The man dipped these bangles into some solution. Right? Now these bangles are made up of gold. So this person is going to dip these bangles into some solution. And thereafter, the bangles which were obtained were sparkling, they were bright, glittering, but their weight reduced. Now, if the weight has been reduced, that means in this solution, when the bangles were added, gold dissolved. So quickly it should come to your mind that gold doesn't dissolve into your any of the three mineral acids. So this solution which he has used is Aqua Regia solution, right? And this Aqua Regia is basically a mixture of concentrated HCl and concentrated HNO3 in the ratio of 3:1. This is exactly what they have questioned. Can you play the detective to find out the nature of the solution he has used? So your answer should be the solution was Aqua Regia, which is a mixture of concentrated HCl and concentrated nitric acid in the ratio of 3:1. Now, the weight reduced. Why did the weight reduce? Because the outer layer of the gold bangles, they dissolved in Aqua Regia, they exposed bright and sparkling layer underneath. But in that process, the gold dissolved and it remained in Aqua Regia, and therefore the weight of the bangles reduced drastically. With this question, I come to the end of this video. If you like my video, do please spare a moment and give it a thumbs up. In my next video, I'll take up the next chemical property of metals, which is the reaction of metals with solutions of other metal salts. So stay tuned to my channel, don't forget to subscribe to it, and do share this video with anyone who you feel might benefit. Thanks for watching, and until next time, take care and stay bonded, my dear learners.